Hello, Ku. Yep. I'm back with day 11. I've managed to keep up this year. Actually, there was one day where I had to not do day 8, but I managed to do the other two the next day. So far the problems have been pretty good, pretty easy, I would say. There were only one or two that were kind of uh, tricky, but also quite interesting. But most are just writing basic for loops and thinking about how you're storing the data. But I guess that's mostly the point of this thing. It's aimed at people who, want to warm up in coding. So problem 11. All right. Monkey in the middle. Okay. As you finally start making your way upriver, you realize your pack is much lighter than you remember. Just then, one of the items from your pack goes flying overhead. Monkeys are playing keep away with your missing things. Keep away. I mean, I know this from The Simpsons, but I guess it's like an American version of piggy in the middle, which is what we called it in UK. I've never heard it referred to as keep away in the UK. Nor have I heard it referred to as monkey in the middle. We always called it piggy in the middle. Okay, well, that's cool. You've never heard piggy in the middle. I guess it is very much a British term for it. I certainly didn't hear it called piggy in the middle on The Simpsons, and that's where I get all my American knowledge from. Simpsons, South Park. So where was I? To get your stuff back, you need to be able to predict where the monkeys will throw your items. After some careful observation, you realize the monkeys operate based on how worried you are about each item. You take some notes, your puzzle input, on the items each monkey currently has, how worried you are about those items, and how the monkey makes decisions based on your worry level. So it's just another way of saying value. Okay. Hello, DIJ. So... Okay, so Monkey Zero, he has 79 and 98. Operation new equals... What? Ah, okay, it's explaining how the monkey decides where to throw it. So, new background today. Yeah, thinking about it, if I go back and look at all my past videos, it's practically a different background every day. I keep moving. That's just, like, staying in one place is boring. That's my motto. Test. Operation. Okay, I don't understand what operation. What this line here means. Test divisible by 23. If true, throw it to monkey 2. Throw it to monkey 3. So old is just some variable that they're changing each time. Okay, fine. To new. Oh, I see. Interesting. They're kind of different arithmetic operations on... It explains below. Yeah, I figured it would. It's just... Normally they explain before they show the example, but yeah. Starting items, worry level. Okay. Operation shows how your worry level changes as that monkey inspects an item. So we could probably use the Python eval function, which will be a nice way of just evaluating these times plus and so on without having to write a parser. One of the great things about Python. Test shows how the monkey uses your worry level to decide where to throw an item. Okay. After each monkey inspects an item, but before it tests your worry level, your relief that the monkey's inspection didn't damage the item causes your worry level to be divided by 3 and rounded down to the nearest integer. Do they never damage the items? Okay, fine. The monkeys take turns inspecting and throwing items. On a single monkey's turn, it inspects and throws all of the items it is holding one at a time and in the order listed. Monkey 0 goes first, then monkey 1, and so on until each monkey has had one turn. The process of each monkey taking a single turn is called a round. Alright, there's a lot to take in here. When a monkey throws an item to another monkey, the item goes on the end of the recipient monkey's list. A monkey that starts a round with no items could end up inspecting and throwing many items by the time its turn comes around. If a monkey is holding no items at the start of its turn ends. Okay. Alright, I mean, this can all be broken up into little steps, so it's not that hard so far. I don't think I need to read this example. I think it's... They've given us all the clear enough information. Chasing all of the monkeys at once is impossible. I don't understand how a monkey could go inspect and throw multiple items if it's starting with no items. Oh no, it's not saying... It's because it receives an item from someone else. Wait, what was the sentence you're referring to? So it's possible that it... I mean, it would do an inspect, and then it does and then it ends its turn because it has no items. I think what they're saying is... Where? Oh, I can't find the line now. Monkey that starts a round. Yeah, so a round, he could be late in the queue in that round. So he starts the round with no items. But when it comes to his turn, he might have received items from other monkeys. So it's round as opposed to turn. Chasing all of the monkeys at once is impossible. You're going to have to focus on the 2 most active monkeys if you want any hope of getting your stuff back. Count the total number of times each monkey inspects items over 20 rounds. Sweet. Keep track for each monkey how many times they've inspected items. Take the 2 highest numbers and multiply them together. Over 20 rounds. Okay. A lot of steps here, but they're all reasonable. The only... Okay, the only tricky bit maybe is the parsing. Well, how have they worded? Well, okay, we need to see this input. Test. Okay, test is always divisible by x. I thought they might have different kinds of tests, and it always says throw 2, so that's fine. The operation... that can be done with Python. Old times old. As n goes to infinity instead of just 20. Well, can it ever... Well, there's no terminating condition, is there? If any monkey has an item, it will throw it. So it will just... there's no, like, stable state, is there? Can you not just hard code this stuff? I mean, for this... I mean, this is the first time we've had an input this small. So, yeah, you could. I think, I'm still though, for this many monkeys and for 20 rounds, it'll be quicker to code it. But yeah, you could do that. And then part 2, we don't know, that might be bigger. And it, they said it ends up to 20. Yeah, but I'm guessing whatever they make us do in part 2 will actually need you to have written some code, so it wouldn't be much of a benefit. Which are the best 2 monkeys to change after infinitely many rounds? Oh, right, because it will cycle. Because eventually it will actually cycle, won't it? So there will actually be 2 monkeys that are... have the most changes in the long run. There's always 2 parts. There's one part they reveal to you, you solve it, and then they give you part 2. And part 2 usually expands on what you've done. Sometimes it's a clever twist or a clever trick. Sometimes, in a couple of times, it's actually been easier than the first part, and just change one thing somewhere. It always varies, so it's always interesting. On YouTube, you can find some people have solved some of these problems in kind of really funny ways. Like, somebody solved it with Minecraft redstone, one of the problems. That was really cool. And someone else used like a physics engine to code like... So there's one with a crane that's moving boxes from between columns. Someone actually just coded it in some game where you have an actual crane that's picking up boxes, which is also very funny. Alright. So... let me just save this input. Oh no, it's obviously way more work. They were doing it to be creative. Because people are showcasing their the way they solved it. So some people are doing kind of like esoteric languages, like brainfuck, or funny ways of solving it in general. I mean, brainfuck used to be on Coding Game. They've removed it. I guess they didn't want to maintain it, but or maybe it just wasn't popular anymore. I'm not sure. Or maybe they just thought it was too vulgar to keep on the website. Alright, let's go. Someone had to write all that starter code. Yeah, the starter code is a problem. Probably whoever was volunteering to do that, like, stopped doing it, and... Would love to see anything complicated written in brainfuck. Well, yeah, I mean, the past competitions and past problems on Coding Game, I think some people did write some pretty complex AIs using brainfuck. Okay, so create a new... Alright. So we've got 7 monkeys. I can just hardcode that number and just do a... Alright. So I'm gonna need a list of... how to... So each monkey is basically a list of items. That's really all we need here. But we can actually hard code the operations here. So I don't actually have to parse the operations from the input. I could just hard code those. I think that's quicker than actually trying to parse it. Actually, yeah, same goes for... Oh, is that what you meant, Ku, when you said hard code it? I thought you meant solve it all on pen and paper. But I guess you meant actually just hard code everything, or like the tests and the operations, but actually run the program using those hard coded tests. That is actually what I'll do, I think. And if part 2 needs... No. Part 2 uses the same input, so it won't be a problem. Alright. Monkeys equals list of lists. Monkeys. Like, I could even just copy everything out. I don't actually need to. Yeah, I meant just hard coding the 7 monkeys. Oh, okay, yeah. In that case, yeah, that actually makes sense. I mean, I can't even be bothered to write parsing for this stuff. I might as well just do that for all the monkeys, yeah. I thought you were commenting on the input being small enough that it could be solved by hand. Alright, so... So I might as well just start copying these in then. So, monkey... I'll do it line by line just so it's more readable. Monkeys dot append... Two, 3, 4, 5, 6, 7. But yeah, part 2 always uses the same input. So 82, 72, 92, 92. Oh, it's 8 monkeys, okay. Should have used Control D there. Keep forgetting these shortcuts. Alright, we got the monkeys items. So we start... So for round in range 20, okay, so we go... I just got... okay, monkey 1. So he takes items from the left of the list. And puts items on the right. We don't really need to care about the inefficiency of lists here, but sorry, no, okay, yeah. Okay, so on a turn, it inspects and throws all of the items it is holding one at a time, and in the order listed. Okay. So... And then it ends up with no items, because they never actually throw to themselves, do they? 0, 2, 5, 1, 7, 4, 2, 6, 5, 3, 7, 1, 4, 0, 2, 5, 6, 3, 6, 3, 1, 7, 4, 0. Okay. So for item in monkeys 0, you can just say operation new equals old times 2. So item, we multiply it by 2. And then we do if item divisible by 17. Oops. Still pressing shift. It's gonna take a long time for me to unlearn shift and start using caps lock. Item wait, what was the test? Just say equals 0 either way. So it's divisible. Okay, throw to monkey 2. So it goes to the right of their list. Okay, so monkeys. And they are 0 indexed. Okay, monkeys 2 dot append item. Else monkeys, was it 7? No, 5. Is that it? I guess so. We just copy and paste that, but change the numbers. It's pretty straightforward. We also need to keep track of... Well, we can do that later. Oops. Okay, we need to copy it like that. So 0, 0, that should be 0, monkey 0, 1, 2, 3, 4, 5, 6, 7. Alright, so that's 0, got 1, item in monkeys 1. Oh, and we also need to clear his list. Monkeys 0 equals new empty list. For round. Oh, round is a built-in. We don't even need to keep track of the rounds anyway. So okay, so monkey 1, item. Let's just change each of these things one at a time. So 2, 3. Damn it. Maybe I should zoom in a bit. How do I zoom in? Control. Not that. I don't know. Why wouldn't it be control and mouse wheel? Alright, 1, 2, 3, 4, 5, 6, 7. Alright, next thing to change. 0, 1, 2, 3, 4, 5, 6, 7. Oh damn, I forgot this one. I can already see, oh, okay, doesn't matter. Keep going the, like, cleaner ways of doing all this, but whatever. Okay, what else? The worry changing. So, times 2, plus 3, plus 6, plus 5. Times 2, plus, was it 3? 3, 6, 5, 8. 3, 6, 5, 8. 5, 6, 7. Times 5, square it, and plus 4. Times 5. Square it. 5. Easy to make some sort of typo somewhere, so... And it was 4, not 5. Alright, now the test says always divisible. So it's 17, 13, 19, 7. 17, 13, 19, 7. They're always prime numbers. 11, 3, 2, 5. 11, 3, 2, 5. 11, 3, 2, 5. And then finally, 2, 5. We've got 7, 4, 6, 5. 7, 4, 6, 6, 7, 4, 6, 5, 7, 1, 0, 2. 7, 1, 0, 2. 6, 3, 3, 1. I think the bulk of this session is actually going to be pretty boring to watch. Very routine. 6, 3, 3, 1, 4, 0. So far, it's not actually that interesting a problem. It's literally just writing all this out. Okay, but that's a skill like any other. Does that cover everything? Okay. Now we need to keep track of... Yeah, big simulation, but we don't really... We also, you know, we don't have to care much about efficiency. I mean, if it were like a hacker rank problem or something, you'd be expected to work with like lists like a million items long, so you'd have to use like a queue data structure or something. Monkey 0 equals... Oh yeah, that's outside the... Yep, thanks for that. Well, you wouldn't actually need a queue data structure, would you? You would just... you just do what... Oh no, this is efficient, what I'm doing. I'm not actually pulling items from the front of the list. I'm putting them on the end. So this is actually efficient. The... Unindented by... Yeah, well, it was actually... It's 4. A tab is 4 spaces in this. So... Now what? We need... Oh, I forgot one thing. So after each monkey inspects an item, but before it tests your worry level. Hang on, I need to... So the first thing... Let me put this back on. I have to do this divide by 3 thing as well. Is my list equals new empty list faster? I would think so, because it doesn't... The old list will just probably hang around in memory until the garbage collector just decides to clear it up at some point. It probably won't. So clear would actually delete stuff, but new list will just reassign the pointer to a new list, but keep the old stuff in memory. But then I never really know what Python is doing behind the scenes. That's why I like Python. Yeah, so in what order does this happen? So it... Alright, it could phrase this a bit better. So it's saying after each monkey inspects an item, but before it tests your worry level. Okay. So it's faster as long as the... Well, I have no idea. That'll be something to test. There could be some reason that I haven't thought of that it's actually slower. I don't know. So this comes after... I don't understand. When this happens. It comes after the operation. Okay, operation is as the monkey inspects an item. Okay, fine. And then after it inspects the item, then you divide by 3. Okay. Is there anything else we've missed? So that's a round. And empty lists, I'm handling that fine because they don't do anything. Okay. They're within 1 microsecond of each other. Okay. But I mean, I suppose for bigger lists, it might be more than a microsecond. Are you testing it for these sizes or like really big ones? Okay, so then this is just the example, and then whoa. Total number of times each monkey inspects items over 20 rounds. So we just need like a hash table or something, or just a list of integers. Okay. Activity. Clear seems to be slightly faster. Okay. Activity equals 0 times 8 monkeys. So after it does the operation, it then item. Wait, did I switch to... Damn it, I didn't switch to the... There we go. I gotta stop forgetting to do that. Okay, so that's dividing by 3, and now activity. So, activity, the number of times each monkey inspects items. So it's basically at the start of its turn, you can add the count to the takeaway is used, whatever. Yeah, I mean, I can't imagine any situation where any situation where I'd really care would be one where I wouldn't be using Python in the first place, I suppose. So activity. So as I build this more and more, I'm starting to see the value in having done this in a iterative way. The only real things I would need to do some sort of branching if condition would be this operation. Everything else is pretty easy. You can just pull items from a list. Okay, so at the start, do activity 0 plus equal length of items. Length of, no, not items, length of monkey 0. Now we have to copy and paste this. All right. Speaking of not using Python, only 30 hours until the coding game challenge. Oh yeah. I'm gonna be coding a lot. How long does it last? Like a month? Or maybe 2 weeks. It's usually 2 weeks, isn't it? Hope deciding to do it this way is not going to screw me in part 2 if they're going to make me build on this and make me copy paste a lot more. I think it's very likely I've made a small typo somewhere, which is just gonna screw everything up. See, the problem is, doing it this way, I can't easily test it on their smaller example. which would be the ideal way to debug an error. Each monkey also knows its operation modulus, true monkey and false monkey. I'm almost tempted to rewrite it that way because I feel like this is open to bugs. Let's see if it actually works. If it doesn't, and I have trouble debugging it, I could actually just rewrite it as one inner for loop. And the only thing you need to override is the operation, and even that, well, yeah, that's not too hard to do. Usually it's like 10 days, yeah. Oh, really? 22 days. That's cool. Do they have a name or theme for it that they've revealed? Finally, we want to do activity. Wait, what was it? Activity.sort. Just put it in reversed order and then say print activity 0 times activity 1. For the operation I'll pass in a lambda, yeah. Five, 6, 5, 9, 5. Okay. Hello, MC2M. Saw this monkeying around. I'm doing Advent of Code, which is like one problem every day on this website. This one involves monkeys, a simulation of monkeys that are throwing items to each other and making decisions on which monkeys to throw to. Not particularly hard, just a lot of hard coding, the way I've done it at least. It's quite possible I made an error somewhere. Right, 5, 6, 5, 9, 5. Oh, it's correct. Alright, part 2. You're worried you might not ever get your items back. So, what? Keep off the grass. What is that a reference to? Tank themed? It's almost always a movie or a game, isn't it? Keep off the grass. I was thinking it might be something to do with the World Cup, although I don't think they'd be interested in using that as a theme. And I wouldn't want them to either. Alright. You're worried you might not ever get your items back. So worried, in fact, that your relief that a monkey's inspection didn't damage an item no longer causes your worry level to be divided by 3. So we take out the divide by 3 bit. You'll need to find another way to keep your worry levels manageable. At this rate, you might be putting up with these monkeys for a very long time, possibly 10,000 rounds. Okay, just change 20 to 10,000. That's it. Okay. That's pretty easy change, unless I'm missing something. We just change 20 to 10,000. I don't imagine we'd have any issues with runtime here. Comment out these, divide by 3s. Alright, I mean, that's... Oh wow, it does actually take a long time to run. Okay. It is 10,000, right? Yeah. Well... Just wait then. I guess it should... I don't see why it would take a long time. 10,000... It could be that it's stuck in a loop. I mean, there's no way it could be stuck in an infinite loop. I've not used a while loop anywhere. We've got 10,000, and multiply that by, I don't know, like 20 or so to account for items. So, like, say, like 100,000, and then like 8 monkeys, so around, like, multiply up to 1 million. So we could be doing 1 million things. That's not that much. Maybe. Okay. Shall I just print increments of 100 or something and see what's going on here? If I for R range from 1000, if R cent 100 0 print R. Can't even reach 100. Okay, something's definitely wrong then. Wait, let's change it to 20 again. Did I break something? So, no, hang on. Well, okay, check when we reach 20. 20, 40, 60. Why would it ever get stuck? Like, it's just moving things around. Are the integers getting too big? Ah, so they want us to be clever. And find a cycle or something. That's probably it. Yeah, because we're squaring the numbers. That is ridiculous. Okay, fine. Do we actually... Okay. So, we're only ever checking divisibility, so we don't actually ever need to keep anything other than the modulus. So... the only thing we... hang on. Well, they are divisible by... We are checking divisibility by different integers, though, so we need to... So we just keep a divisibility table for 17, 13, 19, 7, and so on. And update that each time. So let's stop this. And every time we do an operation, we're just updating that modulus. Alright, this is one of the ones with a clever part 2, it seems. This is more like it. Most of the problems so far is the part 2 has been really lackluster. Okay, so we need to keep track of can also thread this. I don't think threading will help. I think the scale is way too big because we're squaring it regularly, so I think it will explode no matter what. So okay, so we need a divisibility table. So each of these items, instead of being an integer, it's got to be a tuple of 8 moduluses. 17, 13, 19, 7, 11, 3, 2, 5. Which is fine, I can do that. Is there another way of doing this though? I forgot on my number theory. Could I just keep track of the modulus with respect to the... they chose these to be primes. I noticed that, so there was a reason for that. If I just multiply all these together and take the modulus... Hang on, I need to think for a sec. Yeah, if I were to just keep track of the modulus with respect to 17 times... Okay, so the big number is... equals 17 times 13 times 19 times 7 times 17, 13, 19, 11, 19, 7. Eleven, 3, 2. Five. So yeah, this wouldn't have worked if they weren't picking prime numbers for this. So well, it might, but it wouldn't. The numbers have to be co-prime. That's the important bit. All right. So module equals that. So currently, all these numbers are already within that bound. That's fine. What is that number anyway? I mean, it'll be quite big, but manageable. It's that, okay. So every time we do an operation, so item equals item, so we do item times 2, and then modulo. Basically just do that every time. We don't divide by 3. Yeah, that's also why they've removed the divide by 3. Because you can't deal with that. Or you have to use, I don't know, the Chinese remainder theorem or something. I've forgotten my number theory. But I don't think you can. If you're keeping track of the modulo, I don't think you can divide by 3 again. So if item... So these will work, as long as we're keeping it modulo that number. You can if the numbers are prime. Oh yeah, you can, yeah. You need to find the inverse in the field of yeah, whatever, something to do with group theory. Every item has an inverse as long as it's prime, because that forms a group. It's just that operation, isn't it? Hang on, what was that? +6, okay. Item equals item plus 5% modulo. So this should just go back to working in a blink of an eye, I would imagine. Item equals item plus 8. Is this like the only way of doing this? I think this is the first problem they've done which needs a little bit of mathematical knowledge to understand how to solve. That's wrong. Hang on, it was +8. I just copied what was above. Hang on, +8 and times 5. Uh, 6. Item squared. Item equals item times item percent modulo. Is that the... What is that number? Is that the final answer? An encoding thereof. Alright. 7 item equals item plus 4% modulo. Alright, so that's... Wait, what am I printing here? Yeah, the final number. But, computed everything modulo the product of the primes. Yeah, well that is what I did. I was gonna do a list, but then realized you can just do it with the with the product. But are you solving it with your input? Because everyone gets a different input if they're on Advent of Code. I only recently realized this. So it'll be a different answer anyway. Yeah, they give different inputs to everyone to prevent cheating. Correct. Nice. That was a good problem. I like that. Wait, no. Part 2 was a good problem. Part 1 was a bit boring. But I chose to do it in a long-winded way, so it's my fault, really. Like, I could have done it a smarter way, what you said with the lambda and the functions, and yeah, it's actually no fault of the problem, it's a fault of the way I started writing it. So it actually is a good problem. Yeah. And it would have been quicker to code anyway. I felt like the way I was doing it was going to be quicker to code, and then as I kept piling on more things, I realized it wasn't. I never had to read the input. All right. Without importing anything. What did you import? Just to output the proper output, I imported heap q and numpy. Wait, what do you mean by proper output? Why would you need those? Okay. But were you keeping them in lists? Interesting. I mean, looking at that, that seems more work? Maybe not. I don't know. Oh, I see. Yeah, okay, yeah. The way you've done it, that does actually make sense. Okay. All right. Bye.